So we're examining the features of one more polynomial function here. So again, starting with our leading coefficient test. So I'm looking at this highest exponent piece. I can see that that exponent is even. So therefore I know that we are looking at a touchdown graph. Both sides are going to head the same direction, but with that negative leading coefficient, instead of both sides going up, we're going to have both sides going down. So we're going to end up with a graph that looks something along these lines here. So both sides are eventually going to go down. We're going to have some changes of direction in between since we have a higher exponent like 4 that we'll still have to figure out, but we can do that via the graph. So if we enter this function in on our calculator on the Desmos app or on our computer via the Desmos website, we'll eventually zoom in and get a graph that looks like this. So again, clicking on the individual zeros, those are the most important locations for us. We want to see if we get any integer values. And so here we can see that we do, not only do we have an integer value here at -1, 0, but it also bounces off of that location, which tells us that that's a double zero. So when it comes to our synthetic division in a moment, we're going to divide by -1 twice. In the other examples that we've looked at, the graph has always passed through that location on the x-axis. That's why we've just used that value as a 0 once. But this time, since it's bouncing, we're actually going to have to use that number twice. But then we have these other two zeros here and here that are some sort of irrational number that we're going to have to find. And then for graph sketching purposes, we need to identify these other kind of key points here. Got our y-intercept that we can just get straight from the equation. Whatever the non-x number is in our equation is going to be our y-intercept. And then beyond that, we've got these other two locations. So this one's a little bit to the left of -2, and since we're counting by 5s in the graph that we see here, so let's say about 5 is our y-coordinate. Again, this is just estimating for a sketch. And then over here, we're a little bit short of 2, but pretty close to it. And then as I look, so just short of 40, so somewhere between 35 and 40. So when I go back to my graph and I want to sketch it, I think counting by 5, so having 50 be the top and the bottom here, but then we can count by 1s in the x direction. We can stay consistent with that. So again, our zeros, we had one at -2.828, so that's going to be right about here. We had that double 0 at -1, and then we had our other 0 at +2.8 over there. And then those other two kind of points in between, we had one that was at about -2.5, so just a little bit to the left of -2 if I remember correctly, and then up 5-ish. We got a y-intercept of 8. So if we're counting by 5s on the x-axis, it's going to be just short of that second mark. And then finally, we should probably accurately sketch out this other one that goes all the way up to 2 and then somewhere close to 40. So in the end, again, we're just trying to recreate that graph that we had on Desmos. It looks something close to this. But once we have that sketch, now again, it's all about trying to find what is the exact value, what is the square root value that it's associated with those 2.8 and -2.8 locations, taking advantage of the one that was x equals -1, the double 0 there. So that's where we move to our synthetic division. So I've got -1 as my divisor, and then I use the coefficients from the polynomial. -1, -2, 7, 16, 8, and now we add in the vertical direction, multiply on the diagonal. -1 times -1 is 1, -2 plus 1 is -1, -1 times -1 is 1, 7 plus 1 is 8, -1 times 8 is -8, add in the vertical direction, 16 and -8 is 8, multiply by -1 and get -8. And as always, whenever we're dividing by something we know is a 0, we should get 0 as a remainder here. And again, as I mentioned, not only are we dividing by -1 once, but we're going to divide by it twice because of the double 0 feature that we see here. So I'm going to take -1 and I'm going to divide by it again. So if we roll through it, bring down the -1, I've got that here. -1 times -1 is 1. If I add -1 and 1, I get 0. 0 times anything is 0. Bring down the 8. Since I'm adding 8 plus 0 to get 8, -1 times 8 is -8. And if I add one more time, I get 0, which is what I should get. And so now we've gone from x to the 4th to x to the 3rd, and we've knocked it down to x squared. So we have -1 times x squared, or just -x squared, plus 0x, and then plus 8 equals 0. And so now this is the equation that we need to solve to find what the exact value of those two remaining zeros are. So I'm going to add x squared to both sides, so I want that x squared piece to be positive. So we get 8 equals x squared. So now I'm going to take the square root of both sides. So we're eventually going to get x equals, and then plus or minus, as always. Now square root of 8 I can simplify. So square root of 8 I can break into 4 and 2. 4 is a perfect square, so that's going to come out as a 2. So it's going to simplify into 2 times the square root of 2. So we have found the value of those two decimal zeros that we got from the graph. So we've got, for all of our zeros, we've got x equals the -1 that we observed, and we don't need to list it twice, even though it's a double zero. So we've got -1, and then plus or minus 2 root 2 are the other remaining zeros.